This video is about equations of tangent and normal lines. As we know, there is a point on this function y equals f of x is a and f of a. Then the slope of a tangent line equals f prime of a. Therefore, we're using the linear function called the point-slope form of a linear function, that is y minus y1 equals slope x minus x1. We count a as x1, f of a as y1. Then we can plug in here. This will be the equation of a tangent line. For the normal line and a tangent line, they are perpendicular to each other. In other words, we know that slope of normal line times the slope of a tangent line equals -1. So we get the slope of normal line equals -1 over slope of a tangent line. So we get -1 over f prime of a for the slope of a normal line. Therefore, the equation of a normal line will be this. Let's go to guided practice 1. Find the equation of the tangent to a, y equals 3 over x minus 1 over x squared at -1 and -4. Basically, we got to use this formula, y minus y1 equals slope of a tangent line, x minus x1. As we know, the slope of tangent line equals f prime of -1. This is x1, y1. We need to get the derivative of f prime of x. Make sure every term you turn into power form. So 3 times x to the negative first power, we do derivative, minus x to the negative second power, we do derivative. So drop down, you get the 3 times -1 times x to the negative second power, minus. Drop down, -2 times x to the negative third power. Then we organize -3 over x squared. Negative, that's a positive. 2 over x to the third power. Then we plug -1 into this derivative function. You will get the -3 over -1 squared plus 2 times -1 to the third power. That is -3 minus 2 equals -5. Therefore, the equation of a tangent line equals y plus 4. We plug into this formula. x1 equals -1, y1 equals -4. So we get y plus 4 equals -5, x plus 1. You can leave as it is. Now let's go to B. First of all, we need to get the x1, y1. You are given x equals 1. Therefore, f of 1 equals e to the negative first power, means 1 over e. So we get the x1, y1, that is 1 over e. We get this is x1, here's y1. Then we need to get the derivative of f of x. That is e to the negative x power, we do derivative. So we get e to the negative x power times. Using the chain rule, you have to do derivative for negative x, that is -1. So we get the negative e to the negative x power. Therefore, f prime of 1 equals negative e to the negative first power, which means negative 1 over e. Now we can write down the equation of this tangent line. Y minus 1 over e equals negative 1 over e x minus 1. Now let's go to guided practice 2. Find the equation of the normal to a y equals 5 over square root of x minus square root of x at the point 1, 4. This is your x1, y1. So get the derivative of this f of x. You will get the 5 times x to the negative 1/2 power minus x to the 1/2 power. We have to do derivative separately. And we know that 1 over square root of x, when we do derivative, you get the negative 1 over 2x square root of x. For square root of x, when you do the derivative, you will get the 1 over 2 square root of x. So we use this formula. You will get the 5 times negative 1 over 2x square root of x minus 1 over 2 square root of x. We organize, you will get the 5, this is negative 5 over 2x square root of x minus 1 over 2 square root of x. Then we plug 1 into this derivative function. You will get the negative 5 over 2 minus 1 over 2. Therefore, you get negative 6 over 2 equals negative 3. This will be the slope of a tangent line. We're looking for slope of a normal line equals negative 1 over slope of a tangent line. Therefore, you can get the 1 over 3. Or you can remember this way. From here, you have to do opposite reciprocal to get the slope of a perpendicular line. Therefore, you will get the 1 over 3. Therefore, we can write down the equation of a normal line. That is y minus 4 equals 1 over 3 x minus 1. Now let's go to B, where y equals negative 1. So you have to solve for that point, x1, y1. We plug into this formula, you will get that negative 1 equals natural log of square root of x. Therefore, the base is e. We use the concept like log base b of x equals to y. Then you can get the b to the y's power equals to x. So we get from e to the negative first power equals square root of x. E to the negative first power equals square root of x. Then we square both sides. You will get the x equals e to the negative second power, which means 1 over e squared. Therefore, we got the x1, y1, that is 1 over e squared and negative 1. This is the first step. Your second step, we have to work on the derivative. So y prime equals natural log of square root of x, we do derivative. For square root of x, we know that it's x to 1/2 power. So we get the natural log x 1/2 power. Then we do the expansion drop down this 1/2, get the 1/2 natural log of x. So we get the 1/2 natural log of x, we do derivative. That is 1/2 times 1 over x, which means 1 over 2x. Then we plug 1 over e squared to this derivative function. That will be 1 over 2 to the 1 over e squared. Then you will get the 1 over 2 over e squared. That is e squared over 2. Because using the complex fraction, e squared goes to the top. That is e squared over 2. This is the slope of a tangent line. We are looking for slope of a normal line equals. Either you using -1 over slope of tangent line, or you do the opposite reciprocal, that is -2 over e squared. Now we use this formula, y minus y1 equals the slope of normal line x minus x1. You write down the equation of a normal line, that is y plus 1 equals -2 over e squared times x minus 1 over e squared. Now let's go to C. You are given x equals pi over 4, so we can get the y equals 1 over sine 2 times pi over 4. You will get the 1 over sine pi over 2. Sine 90 equals 1, therefore equals 1. So we get the x1, y1. You will have pi over 4 and 1. We need to get the derivative of f of x, that is sine 2x to the negative first power. Then we do derivative. You have to use power rule first. -1 times sine, here's the negative second power, 2x. Then you multiply using the chain rule. For sine 2x, you will get the cosine 2x. Then for 2x, you do one more derivative by chain rule, you will get the 2. Therefore, you organize that's -2 cosine 2x over sine squared and then 2x. Now we will plug in pi over 4 into this derivative function. You will get the -2 cosine 2 times pi over 4. Then sine squared 2 times pi over 4. 2 times pi over 4, that is pi over 2. Cosine 90 equals 0, so 0 over 1, that equals 0. This will be slope of a tangent line. Then slope of a normal line equals -1 over 0 means undefined. For undefined, your equation will be x equals, here, pi over 4. This will be the equation of a normal line. Let's go to guided practice 3 for A. Find the points of contact where horizontal tangents meet the curve y equals 2 square root of x plus 1 over square root of x. Horizontal tangent line, that means y equals y1, basically. In other words, for this slope of tangent line equals to 0. We will work out the derivative for this function, that is y prime equals 2 times, using this rule, that is 1/2 square root of x. Then plus 1 over square root of x, that is negative 1 over 2x square root of x. Let's organize. You will get 1 over square root of x, because this is reduced, minus 1 over 2x square root of x. This will be slope of a tangent line. That's the derivative. We will set up equal to 0. So we get 1 over square root of x. I move this one over here, equals 1 over 2x square root of x. We multiply by square root of x, both sides. You will reduce. That is 1 equals 1 over 2x. Then you can do cross multiply. X equals 1 over 2. Then you need to plug into the original function to get the y1. So you get the f of 1/2 equals 2 times square root of 1 over 2 plus 1 over square root of 1 over 2. As we know, square root of 1/2, that equals square root of 1 over square root of 2, which means 1 over square root of 2. And you keep simplify, you can get square root of 2 over 2. Therefore, 2 times square root of 2 over 2 plus, this will be square root of 2. Reduce, you can get the 2 square root of 2. Therefore, the point of contact, this point will be 1/2 2 square root of 2. Now let's go to B. Find K if the tangent to y equals 2x third power plus kx squared minus 3 at the point where x equals 2 has a gradient 4. When you say has a gradient 4, definitely that means derivative of f of 2 equals 4. So first of all, we need to get the derivative of this function. That is 6x squared plus 2kx. Then we plug in derivative of f of 2 equals 2 squared plus 2 times 2 times k. It will be equals to 4. This will be 24 plus 4k equals to 4. So minus 24 both sides, 4k equals negative 20, k equals negative 5. Let's go to C. Consider the curve y equals a square root of x plus b over square root of x, where a, b are constant. The normal to this curve at the point where x equals 4 is this. Find the value of a and b. First of all, we know the slope of a norm equals negative 4. Because for this linear equation, I can write down y equals negative 4x plus 22. Therefore, the slope is negative 4. That's its norm. Then we will get slope of a tangent line equals do the opposite and the reciprocal is 1 over 4. In other words, f prime of 4 equals 1 over 4. So we have to work the derivative of this function first. That is y prime equals a times 1 over 2 square root of x plus b times negative 1 over 2x square root of x. Then we plug in 4 to this derivative function. You will get the a times 1 over square root of 4 is 2, so it's 4 plus b times, here's negative 1. This will be 8. 8 times 2, it will be 16. This number will be equals to 1 over 4. So let's organize. You will get the a over 4 minus b over 16 equals to 1 over 4. Then the LCD will be 16. Therefore, you will get the 4a minus b equals 4. This is the first equation. Then you will get the second equation by doing this. When x equals 4, we plug in here. You will get the 4 times 4 plus y equals 22. 16 plus y equals 22, which means y equals 22 minus 16, that's 6. In other words, we have 4, 6. This point is on the curve here. Now I plug in, you will get the 6 equals a square root of 4 plus b square root of 4. Then 6 equals 2a plus b over 2. Everything multiplied by 2. You will get the 12 equals 4a plus b. So I got the second equation. I will write down here. This is a 12 4a plus b. We add this. You will get the 8a equals, this is gone, 16. A equals 2. Then you plug into any function. I will plug into this. 4 times 2 minus b equals 4. So you get the b equals 4. B equals 4. This is the final answer. Now let's go to D. Show that the equation of a tangent to y equals 2x squared minus 1 at the point where x equals a is 4ax minus y equals 2a squared plus 1. If you are given x equals a, you can get the x1, y1. Your x1, that's a. y1 is plugging here. That is 2a squared minus 1. Then we're looking for the slope of a tangent line. That is y prime. It will be 4x. Since the x equals a, therefore, you can get the slope of a tangent line at x equals a equals 4 times a. That's 4a. Therefore, I use this formula. You can get the y minus 2a squared minus 1 equals 4a x minus a. We organize. This is a distributive property. Y minus 2a squared plus 1 equals distributive property 4ax minus 4a squared. Check this equation. We got to turn it into this equation though. So I will move y over here. Then negative 4ax move over here. Remember you change the sign. So you get the 4a squared minus 2a squared plus 1 equals 4ax minus y. Combine like terms, 2ax squared plus 1 equals 4ax minus y. So we get the 4ax minus y equals 2a squared plus 1.